Hello, guys, and welcome back to Bright Founders Talk from Temi, an international software development company that designs, builds, and delivers software from sustainable businesses and promising startups. Guys, today, as you can see, we've got another new guest with us, Brendan Richardson, co-founder and CEO at Astraea. I'm really happy to have Brendan on today because this is our second try due to our fault. We had the sirens go last time, so we had to cancel the program, but Brendan happily joined today. So I'm really happy to have him here. Brendan, hello, how are you?
I'm doing great. Happy to be here as well. Glad we can make it happen.
Thank you for coming on. So let's talk a little bit to start off with. What is Astraea, what you're doing? So let me just give a short introduction, and then you'll be able to correct me and give us a much more succinct one. So Astraea is a benefit corporation providing a SaaS platform that makes imagery-derived insights from accessible and enables an enterprise-grade space strategy. Brendan, give us a little bit more about what you're doing. Give it more concise. Give it, you can do 100.
Yeah. Translate that into human normal speak.
Exactly.
Yeah. So essentially, we have a cloud-based platform that enables any business or organization or nonprofit to easily access and analyze with machine learning and AI, satellite imagery, Earth observing satellite imagery, and other geospatial data. So essentially, what we try to do is to put the capabilities that have always been sort of embedded in the military or the intelligence community to leverage kind of anywhere, anytime satellite data into the hands of companies to help run their business more efficiently, or nonprofit organizations to address climate change and water crises, food crises, things like that. It's all this data for good. And that's the idea, is to basically put the power of the data into the hands of the people that can do the most good with it.
So this started at 2016. Yeah, so founded in 2016. How long were you working on the idea before you actually got it going?
Not that long, actually. We started the company kind of on a very short conversation with a very smart scientist at NASA, who had overseen a team at NASA that had helped a now relatively famous archaeologist named Dr. Sarah Parchak use satellite imagery from NASA in the infrared band to find previously unknown archaeological ruins. So it's basically called space archaeology. Sarah Parchak has written a couple books about this now, given a bunch of TED Talks about how they do this. But it's essentially using infrared satellite imagery to detect very subtle but real changes in the infrared reflection of vegetation that's growing above archaeological ruins. So the vegetation that's growing above the limestone walls, up to about 9 feet below the surface, reflects in a slightly different IR band because it's ingesting a different mineral content than the vegetation growing right next to it. And you can see that from space in this imagery. Wow. And so now it's kind of like having an MRI of the ground, but being able to see, instead of seeing bones or organs inside the body, you're seeing limestone structures underneath the surface. And that technique has now been used by Dr. Parchak and others to discover well over 1,000 previously unknown archaeological sites all over the world. So the idea after that conversation sort of sparked this, wow, there's lots of off-label uses for satellite data that people are thinking about. Let's go see if we can do some of that stuff, because we were data scientists and software engineers, not necessarily remote sensing folks or satellite experts. So we started down that path, trying to come up with a killer idea, killer app for using satellite data for commercial purposes. Quickly realized that, gosh, we're not the first to think of this. There's lots of folks trying to use this data, both in academia, but also in the private sector and certainly in the government. But everybody is struggling with the same challenges with this data. It's really hard to get. It can be expensive. Some of it's free, but lots of it's private. And even when you can acquire it, it's really big. It's very heavy data. It's dispersed in all these different locations. It's not just one repository of satellite data from everybody. And when you get it, it's highly dimensional. So it's not like a stock price time series. It's got spatial resolution, temporal resolution, i.e. the revisit rate. It's got spectral resolution, and all those things are different depending on where it's coming from. And then it's got time. And so analyzing it with machine learning is not trivial. And so we did it for a couple things, but realized, wow, this is not something your average analyst can do. So we built the software to abstract that complexity away and make it vastly simpler and, more importantly, vastly more cost efficient to do it for everybody. That was kind of the that was the journey once we had the initial idea, which turned out not to be the thing that we really did.
I've got quite a few questions which have come from that straight away though, but I want to start with, where did the idea come from? So you were saying you were having a conversation at this time, but were there any kind of inklings you had before this that this is something that you wanted to concentrate on?
No. And that's probably a symptom or an artifact of my background, which is I used to be a venture capital investor. So I describe myself as a recovering VC. And as a venture capitalist, what you're really doing, you're not the smartest person in the room. You're always trying to find the smartest person in the room with a big idea. And when you find that person and they can describe that idea and why it's so important and that it's solving a hard problem, those are the kind of folks that you want to invest in and build startups around. So that's kind of the lens that I look at the world through. So when I find somebody with a really compelling idea that seems like, wow, this could solve lots of really hard problems across many, many sectors, that's something I lean into. And that conversation sparked that idea that, wow, if we could enable people, or we could go use this satellite data is growing exponentially, but even today, 95% of it still goes unused. There's so much of it, but it's so hard to extract insight from it that's a hard problem to solve. But if you can solve it, it's quite worth solving because you can do all kinds of things with it.
Where do you get this data from, though? Where does it come from? Where do you go and get the satellite data from? It's not something you can just jump onto the internet and get.
That's right. So today there are probably 40 to 50 organizations that are operating satellite constellations, that are capturing this Earth observing imagery. Some of those are the obvious ones: NASA, NOAA, the National Oceanic and Atmospheric Administration in the U.S. The European Space Agency operates lots of satellites that capture this data, and frankly, the best data of all the publicly operated constellations. The Japanese Space Agency. There's lots of national assets that are capturing data. By and large, most of that data is free, available to the public, but not, as you say, in some repository on the internet that you can just go search. They store that data in basically large cloud-based distribution kind of hubs, and it's accessible by academics. Anybody can access it, but it's not easy. It's quite complicated to do it. Requires some technical expertise. On the other side of the equation, there's probably now 30 to 40 private satellite companies. Many of them have been backed by venture capitalists in the last 5 years, 10 years, that are putting up what are called CubeSats or microsats. They're much smaller. They're much less expensive than the things that NASA or ESA puts up. And they're capturing, they get put up to capture a very specific type of data. So there's probably 3 constellations about to launch in the next 12 to 14 months that are only going to detect methane. Everybody wants to track methane and methane emissions because it's a very potent greenhouse gas. And so it's now quite affordable, relatively speaking, for investors to fund a methane-specific constellation to go detect those emissions. Likewise, there's private companies that provide much higher spatial resolution imagery than you can get from Sentinel-2 from ESA or NASA. So you can get Google Earth kind of images, very, very crisp, very high resolution, 30 centimeters from about 1,500 miles up off the surface of the planet. Pretty amazing technology, but it's private. And so their business model is to sell that imagery to the U.S. government, other friendly governments, but also large commercial players. And so we use all of it. We use the free data when it's prudent to do so and solves a problem. But if we have to buy the data, we have data partnerships with a good number of those private constellation operators as well.
We're going to talk about the future a little bit later on, because obviously it's very much interesting for me to know where this is going to go, how far it can go, and how far it can actually develop to actually be competitive. But we'll talk about that a little bit later. Before we do, I want to go right back to the beginning, to the MVP part. And you said that at the beginning you found kind of some difficulty and you had to build your own system yourself. You're working with machine learning, and you couldn't find something that works, so you had to go about building it yourself. Talk to me about this beginning moment, the MVP.
So the first thing that we started to do and work on was, with enthusiasm, was, gosh, we can, people are finding archaeological ruins. Let's go find something that's really valuable to people. Gold, I don't know, lithium, rare earth elements. Let's go predict earthquakes. You can imagine thousands of things you might dream up to go find with satellite imagery. And we started working on them, and quickly realized, we're not the first to think of these things. There's other people working on them. And as we started to do it, it became clear that, well, two things became clear. One, and as we were talking to investors at this time, every investor wanted to know, what's the killer app? What is the killer app that's going to scale and make you guys a super valuable company? What is the thing that nobody's thought of that you can go find with satellite? And frankly, we couldn't think of one. We couldn't come up with one that if we had built it, there was enough people to pay us, some amount of money that all wanted that thing, or that there was, a very small handful of customers that would pay us a lot of money each to only have that information to themselves. Mm-hmm. And so we just never got conviction that there was a killer app. But we did see that, across everybody working with this data, there was this challenge, right? It was really hard. It was complicated. It took months and oftentimes years to go from getting the pixels off the satellite constellation to getting the insight. And that seemed to us to be it's a horizontal thing to solve. But if you solve it, you can enable lots of people to do all kinds of interesting things. So that's where we focused our time and energy. And we were kind of building these tools for ourselves while we looked for the killer app. So that was a relatively easy pivot to make, at least technically. The MVP, in typical startup fashion, we were like, we're going to build the world's most amazing platform to be able to find, discover, ingest, analyze, and then export insights from satellite data. And because we knew that, data scientists, there's lots of data scientists out there. There were fewer then, there are more now. But we really wanted to enable anybody to use this data. So we had this entire visual programming language that we were embedding for the machine learning and AI. Mm-hmm. It was like a Ferrari or a Formula One race car. And we started showing that to people, and they were like, I just need a Honda. I need to get from here to the grocery store. I don't need to go 250 miles an hour. I never drive on a track, right? I don't need wet tires and dry tires, and I don't, all these things. And so we slowly started to pare down, the entire soup to nuts, and said, we'll get to those other things later. What's the real problem to solve now? And it turns out that, so the realization was machine learning and AI was really cool. And everybody was it was super buzzy. Investors loved the concept, but there just aren't that many people that are at that point where they're ready to apply, train a big model and drive AI into satellite data. Most people are starting from way further down the chain, which really is just like looking at Google Earth, right? That's where most people had started in businesses. They were like, we look at Google Earth, it's amazing, but Google Earth, those images there's no timestamp on them. They're not from yesterday. They're from, and it depends. Like if I look at my house, it's from 2 years ago. If I look at my childhood home, it might be from yesterday. There's no consistency to when those images show up or connect to each other. And so most people are like, I'm ready to take the next step. I need Google Earth-like capability to see things, but I need to see more recent imagery, and I need to be able to go back in time and see how things have changed. And so that was really the MVP, the ability to give people access to this, dozens, hundreds of petabytes of satellite imagery in an easily accessible way. So it was connecting to all these repositories, being able to pull that data in on the fly and show people thumbnails of the images so they can figure out, oh, that is what I want to see, rather than just a tabular database list that took people. You had to have a lot of expertise to understand what you were looking at before. Now it's all visual, and that's through our platform. That was MVP number one. Yeah.
Number one. Yeah. Do you feel now, obviously 7 years have gone by since founding. Do you feel now people have the need more for this Ferrari? They've gone from the Honda to the Ferrari, or is it staying at the Honda?
It's a range. So just like in the car world, lots of people need Hondas, but some people need Ferraris, or some people need off-road vehicles, right? Some people need pickup trucks. Some people need, there's a whole range of things now that companies and organizations want to do or are doing with satellite data that is now consuming a lot of that functionality that we first envisioned. It's not necessarily a function of size of the organization, but oftentimes there are large organizations that have been using satellite data for a long time, longer than we've been in business, that have built up their own sets of capabilities. But when they see our platform and our tool, they're like, oh, this is solving all of the things that I need, and it's all in one tool, and the workflow is efficient, and they can modify that workflow on our platform. They can keep all of the machine learning and AI inside their four walls rather than in the cloud if they want to. They can bring their own data into it. It gives them a lot of flexibility. And so they're using the entirety of the platform. They're really flexing the all the features and showing us, leading us to where the future of the platform needs to go, because they're kind of the power users. But I would say 60 to 70% of our customers aren't those power users. They're more somewhere between a Honda and an SUV or a pickup truck. And it just depends on what they're doing with it, but they use, the ability to get to all the data, or to one specific type of data that was hard to get to or too expensive to get to before. They may or may not use the machine learning, but some of the more obvious features are things that they just love, which is the ability to see this imagery and then annotate it, label things, and then share that across the enterprise with other folks, be able to, collaborate on imagery, go back in time and look at that same place, same image, but from a year ago, and see and to note what's changed. It's really just the ability to kind of share around this data for whatever purpose they're using in the business. And then lastly, the most exciting development on the platform is something that's come around in the last 2-3 years. Now that all these venture-backed constellations are up there, one of the things that a lot of them are enabling for customers and through our platform is tasking. So you can now come to our platform, look at something with free data, and if you see something in that free data that you want a closer look at, so instead of 10 meter or 30 meter resolution, you really want a 30 centimeter or 50 centimeter image of that, you can push a button and it automates a tasking order to one of our satellite partners to go take a high resolution image of that thing in the next 24 to 48 hours for you.
Wow.
And it will show up in your UI. And the 24 to 48 hours is really just as the satellite passes over. Sometimes what you're looking at is covered in clouds. They just want a clear sky look at it. And you will get a Google Earth-like image.
And this is a very, very new kind of concept.
Yeah, in the last 24 months or so, these constellations are now enabling tasking, and it's shockingly affordable. So it used to be that you could task, but you'd get in a queue. You'd specify a priority, like how important was this to you, and depending on the priority, you would pay somewhere between $5,000 and $20,000 for that tasked image. Now it's a few $100s.
One.
So it's come down, an order of magnitude in price to be able to do this. And that's kind of a game changer for a lot of companies that it's spurring a lot of companies to now go, okay, this could be really useful because it doesn't cost millions and millions and millions of dollars to analyze imagery.
Tell me a little bit about machine learning and AI. How are you using machine learning and AI? Let's start there because I want to go through the progression of how it's changed through your journey. So how are you using it?
So machine learning is really powerful when you have something that you want to do with this imagery, but over incredible scale, either the geographic scale or frequency. So with imagery, it's mostly over geographic scale. So I'll give you a couple of examples. A few years ago, we were at a solar conference, a solar renewable energy conference. And it was in the US, and somebody on a panel asked the question of the audience, which were all solar energy experts and executives building, utility scale solar. Does anybody know where you can find the of the moment amount of installed solar in the US at today? Like, how does anybody know where we can find how much solar is actually installed in the US? And we were in that audience kind of just, listening, and we thought, how is that not known? How is it not known how much solar has been installed in the U.S.? The U.S. is an information-rich country, like data everywhere about everything. Why is somebody asking? It seems like there should be an obvious answer to this question. The reality is the way that the U.S. Energy Information Administration reports on energy assets is that they collect it through sort of some antiquated means. They coalesce it and then they publish it, and they publish it once a year. And that once a year, by the time it gets published, is 9 to 12 months old data at best. And in the meantime, the solar industry is growing so quickly. Depending on who you listen to, it's somewhere between 20 and 30% a year, or maybe higher, of new installations, and therefore new gigawatt capacity, that by the time that EIA data comes out, it's outdated. You're looking in the rearview mirror like a year ago. So the person was really asking, did anybody have like a real-time assessment? And we thought, that's a perfect use case for satellite data. You can train a model, a computer vision model, to identify in all this satellite data, solar installations above 3 megawatts. And so that's what we did. We took free data from the European Space Agency, Sentinel-2. That satellite data captures every spot on the ground every 5 days. We trained a model by looking at that data with known utility scale solar installations and labeling those. Fed that into a model, trained a model to basically find those other things, like things, and then scored it across the continental U.S. at times 5 years. So we took 5 years of data and trained that model to go find all solar installations above 3 megawatts for the last 5 years. And what we so the machine learning thing is, once we trained the model, and that took a little while, maybe 3-4 weeks, maybe a little longer, with a couple of data scientists iterating. You know, the model doesn't score perfectly every right out of the bat. But once we got the model to the sufficient precision and recall, when we scored it on 5 years of the entirety of the continental U.S., which for the equivalent of about 29 million square miles of land, it on our platform in the cloud, it took about 7 hours to do that, and at a direct compute cost on AWS of less than $1,000.
Wow!
So, and it returned, tens of thousands of solar installations, and which was about 30% more than was in the EIA database, which sort of confirmed the fact that since the last time the EIA, published this, there's been a 30% increase in gigawatt capacity in solar, and here they are, right? Because we looked at them year by year. It was kind of like, yeah, we can do much better capturing this near real-time information with satellite data than we can through the typical way that this data has been collected in the past. But only because machine learning scales in that way. Once the algorithm gets trained, you can go score it on as much geographic area as you want, very, very, very efficiently. We've done the same in China for solar, for cement plants, for a customer wanting to find cement plants are very, very big CO2 emitters. And there's a lot of them in China that are unrecorded and don't show up on anybody's ownership list or database. You can train a model to find cement clinkers. Yeah, they're very distinct in the way they look, and we scored it across mainland China, and sure enough, about 50% of all cement plants don't show up on any government database in China.
Tell me a little bit here about, I've just got a few more questions for you, but first of all, which is the sphere where you find most interest from? Because obviously we were talking about military intelligence, energy. Where do you feel, or where is your data mostly coming from? Where do your clients come from?
On the commercial side, I would say the largest sector that we work in is renewable energy. It's growing incredibly fast. If you sort of follow renewable energy, it's about where do you put the solar panels or the wind towers or the hydroelectric dams. Very geospatially driven. And so that means that satellite data can play a big part in locating these things, but also monitoring them once they're built. And we don't work today with any traditional energy companies like oil and gas or hydrocarbon extraction, et cetera. And we would, if those organizations were using what we do and our platform to transitioning to renewables. Mm-hmm. So we want to support the energy transition and the decarbonization of industry. And we do that through renewable energy today, and hopefully a lot broader in the future. The other sectors that we work in are ag. Ag's been a big user of satellite data for a long time, so it's an obvious one. Real estate, sustainable real estate development in particular. We work with a number of real estate investors and developers to understand the ecological impact of what they may or may not build and where. And then conservation and what I'll broadly call ESG. The nature conservative ESG is environmental, social, and governance. It's basically an acronym that says all organizations should basically be thinking about their environmental impact, their social impact, and have good governance. And it's a big buzzword in the U.S. Lots of investors are now building ESG friendly portfolios. They're trying to measure those companies that they may or may not invest in on ESG metrics, like how good are they on the environment, how good are they on social issues like diversity, equity, and inclusion, how good are they on governance, are they, is it a bunch of the CEO's buddies on the board, or are they a diverse board with, looking out for the shareholder, so on and so forth.
Interesting.
So enabling satellite data has a real part to play in enabling investors in particular to understand the E of ESG, the environmental impact that companies have in their supply chain footprint, in their operations, so on and so forth. And then we work with nonprofits. So our first customer was the Nature Conservancy. So they've been using satellite data for a long time. We work with them and many of their chapters to do it in a more efficient way.
Brendan, thank you very, very much for your time today. It's been amazing to pick your brain and hear everything that you're doing, because it seems something close to NASA is how it seems. It seems something very, very amazing. So thank you for your time, Brendan. It's been great.
Yep. Thanks, Matt. Thank you very much.